Hey everybody, this is a little bit of help for Principles of Algebra Geometry, section 1.3. Here in 1.3, we're going to be working on turning words into mathematics. It's not the simplest thing to just say, how do we turn the way we talk about problems in the real world into equations that are solvable or expressions that we can work with. And so there are certain words that we kind of want to emphasize that they have meaning to us. And so as we look at this assignment, 3 through 21 is essentially what we're working on here. It's really important that we look for certain key terms. For instance, more than, okay, product, divided, of a number, that means something. Difference, quotient, that's division, right? Sum, that should tell us about addition. More than. These ones here, less than. Also we have square, we have times, twice, and again we're going to see this phrase less than. Of all of the phrases, most of them are pretty self-explanatory. More than is going to mean to add. Divided obviously means division. Sum is going to be to add two things. The one that gets us into a little bit of trouble is actually this less than. More than technically is the same issue, but we can get away with it a little bit because the order of addition doesn't really matter. The order of subtraction does. So for instance, if I say 5 less than x, a lot of people will want to write 5 minus x. That's actually backwards. And here's how we can tell. Let's pretend that x is 10. If I said 5, well, let's make this, I'm going to change my number here a little bit so we don't get lost in the numbers. 6 less than 10. If I asked you to tell me what number is 6 less than 10, you'd start at 10 and you might count down 6 spaces. And you'd end up with this equaling 4. Now the question is, what math problem can you use 6 and 10 with to create the 4? 6 minus 10 is not positive 4. It would be a negative 4. So we're going to instead do 10 minus 6. And that's how we'd write this. So let's say that I had 5 less than x. Okay? Just like I had 10 take away the 6, here I'd have x take away the 5. Notice it's 5 less or taken from x. Okay? So that's one of those things that's going to build up a lot, but we're trying to create these kinds of expressions from the language that's used above. Let's take a look at questions like 17. Each person's share, if P people share 16 slices of pizza equally. So we got 16 pieces of pizza, right? And if I want to share it equally, we have to ask what kind of math is used to share equally. When we talk about taking a candy bar and we want to split it into 4 equal-sized pieces, the math involved in that is division. We would divide it up equally. And so we want to take our 16 slices and we want to split those or divide them so that everybody gets the same amount. Well, if I had 4 people, I would divide by 4. If I have 2 people, everybody gets 8 pieces, but I would divide by 2. So however many people I have, I want to divide by that. They didn't tell us how many people. They said it's going to be the letter P because we're not sure yet. And so we will put the letter P here, representing whatever that turns out to be. If I end up with 5 people at the party, I'll divide by 5, have a leftover piece. If I end up with only 3 people, I divide by 3, and so on. And so this is an example of an expression that I could use later to solve the problem once people show up to the party. These are the kinds of expressions that we want to be able to build using the understanding that we have of what does the word difference mean, or what does quotient mean, and things along those lines, okay? You guys are going to have some questions. We'll talk about it in class. Some of you will finish this real fast, and good luck, and we'll see you in class.